colliding cars and chemical reactions. What on earth have they got in common?
Quite a lot. You see, when two chemicals react, it's because their particles are colliding with each other. We call this the collision theory.
So two cars colliding is just like two chemicals reacting with one another?
Yes. The chemical particles need to collide in order to react.
So it's the collisions between particles that make chemical reactions happen?
Exactly. Collisions make reactions. So more collisions means more reactions.
So does that mean if we increase the number of collisions, we can speed up the chemical reaction?
Yes, good point. There's 4 things we can change to cause more collisions. The first is temperature. Look at these particles here. When they're cold, they move slowly, but as they heat up, they move faster. The faster they move, the more collisions they have, and the collisions are harder.
So heating up the chemicals speeds up the reaction because the chemical particles are colliding with one another much harder and much more often.
Exactly. Now, the next factor which changes the speed of a reaction is the concentration of the chemicals.
What? Chemicals have to pay more attention to what they're doing?
In this case, we mean how many particles there are in a certain area. A high concentration means more particles, like here.
And if there are more particles, it means we'll get more collisions. And more collisions mean a faster rate of reaction.
Absolutely right. Now, the third factor which changes the speed of reaction is surface area.
Surface area?
Yeah. Surface area is just how much of a chemical is on the outside surface. Look at this strip of magnesium reacting with an acid. Some of the magnesium particles are on the outside surface, but most are contained inside the strip. But these are covered up and can't react with the acid until the outside particles have reacted away.
So the particles on the outside of the strip need to react with the acid and then leave the strip. This then exposes the next layer of particles, which can then react.
Yes, and that can be a very slow process. But if we use magnesium powder instead, all of the particles are on the outside and exposed to the acid.
So the reaction happens much more quickly. So by having a larger surface area, the magnesium is really just enabling a larger number of its particles to go and collide with the other acid particles.
You've got it! Which brings us to the 4th and final way of speeding up reactions. Catalysts.
So how do catalysts work then?
Well, some chemicals need a helping hand to encourage them to react. This is what a catalyst does. They're chemicals which either speed up or slow down a reaction without getting involved in the reaction themselves.
That's just like a chemical dating agency, helping the chemicals to get to know one another.
Yeah, kind of. And the catalyst will remain unchanged at the end of a reaction.
Okay, so the 4 ways of speeding up a chemical reaction are by increasing the temperature of the chemicals, by increasing the concentration of the chemicals, by increasing the surface area of the chemicals, or by using a catalyst.
Hey Callum, I think we'll make a chemist of you yet.